All right, so let's get into it here. So, of course, this is all on your notes. There's nothing to fill in here. It's just telling you if you're going to add them, just like I said, you're basically adding the corresponding entries together. Now, one of the things you just have to look out for, and this to me makes common sense, okay, they have to have the same dimensions. If you're going to match up the corresponding entries, they need to be the same size matrices. Otherwise, you can't match up everything, okay? We're also going to see, this is super easy too, we're also going to do equality of matrices today. We're going to have two matrices set equal to each other. They have to have the same dimensions, of course, if they're equal. And same thing, you're going to just match up the corresponding entries and set them equal. It's very simple. We're going to do scalar multiplication today, which basically there'll be a number in front of your matrix. You multiply everything in the matrix by that scalar. All right, let's do it. So here's an equality one. So notice they're the same size, both 2 by 2s. Find x and y. Match it up. So x is our first entry here. So x equals -4. Oh, nobody gets this one wrong. Okay, and then of course we're going to do y. Just match it up. Y equals 22. Any questions on that? I know, it's riveting stuff today. Okay, next up, bigger matrices, very exciting. We have x, y, and z. Okay, I'm going to do them in order. I'm going to start with x, of course. What is its corresponding entry in the first matrix? What number? 5. So set them equal. You're going to have to do a little algebra. Big deal. Solve that for me for x. You can do it in your head probably. X is what?
-1.
Got it. Yeah, so fun, so fun. Okay, let's do y. So I find my y expression. What number does that correspond to in the first matrix? 12, probably. Already got the answer in your head. Y is 4. This seems way too easy after Gauss-Jordan. I don't like it. Okay, 3z minus 14, what does that match up to? 4. Solve it. You can do that in your head. Z is what? 6. So there is equality of matrices. Any questions about that? Pretty exciting, I know. Okay, let's do adding, subtracting, scalar multiplication. So this is just why the notes are so long, because we have to do 4 different operations, so we're going to have 4 matrix answers. So we got kind of some room here. Same size as 2 by 2, so I'm going to start with a plus b. I'm going to do that in red. So again, literally, you're matching up the entries, and I'm going to add them. So I'm going to do 1 plus 2. Now, it doesn't matter what order you do it. We've got to do them all. I'm going to do the column here. I'm going to go underneath. 2 plus -1. Then I have -1 plus -1. And then I'm going to do -1 plus 8. And that is matrix addition. I know, it's exciting. Okay, a minus b. Careful on the signs always, right, when we're subtracting. So I'm going to start top left. What's 1 minus 2? 1 minus 2. We're lively today. Okay, I'm going to do 2 minus -1. 2 minus -1. 3. Thanks, Tom. Okay, -1 minus -1. 0. And our final one, what's -1 minus 8? All right. So this is why there's so much space. You just got to write out all these matrix answers. All right, next up we've got to do 3a. So here is an example, if I can talk, of scalar multiplication. All you have to do is multiply everything in a by a 3. Wow, okay. So 3 times 1, 3 times 2, 3 times -1. That was exciting. I know, this seems way too easy after all this Gauss-Jordan. All right, purple. I'm going to do the 3a minus 2b. Well, I've already got 3a here. You know I like to be dramatic, then right out of the word. So we already did 3a. I'm just stealing it from above. And then we're going to do minus 2b. So remember, order of operations, I'm going to multiply before I do the subtraction. So I'm going to do 2b here. So I'm going to take b, run a 2 through everything, and then I'll subtract them at the end. So b times 2, so I'm going to have 4, -2, -2, 16. So I did the multiplications first. Here was my 3a. We just stole that from above. And now I'm going to subtract them out and be done. So 3 minus 4. 6 minus -2. -3 minus -2. -3 minus 16. Now, I can't help myself. I just have to make one comment. Every single year I have somebody get that purple one wrong. And it's a sign error. Because I have people doing this. They'll do 3a. They distribute -2 to b, which you could do, but then they subtract them. Is that the same operation? Is that equivalent? No, minus the negative is really what? So if you're going to distribute a -2 through b, which I'm not saying you can't do, you can, but you're not going to subtract them, you would have to. Is that an equivalent expression? Yeah, so I know this is common sense. We know, multiplying, we know adding, subtracting, but just be careful of your signs. Don't do anything goofy because there's no reason to get that wrong. Okay, let's do another. How am I going to do a plus b?
You're not.
I'm not. They're not the same size. They don't match up. They're not corresponding. So I'm just going to write not possible. Or NP, I guess, if you want to abbreviate. A minus b. Can you do a minus b? Okay, so there's how I'm rolling with that. Can you do 3a? Yeah, we can still do 3a. Okay, run a 3 through a. 3 times 6, 3 times -1, 3 times 3. And then the last thing it asked you for, of course, was that 3a minus 2b. I mean, we could do the 3a and the 2b part, but can you subtract them? No. Yeah, I like a nice not possible. Okay, so any questions on adding, subtracting, or scalar multiplication? Too easy. All right, too easy, way too easy. Here we go. So this is just some properties just to show you. You don't have to get like carried away and have these all memorized. Of course, just showing you, this is the same of just integers. And it, of course, applies to matrices. 2 plus 3, 3 plus 2, it's all the same thing. The order you add in doesn't matter, okay? Same thing what they're showing you down here. 1 times a is the matrix. Yeah, that's pretty exciting stuff. And of course, you can distribute your scalar through. You could add them first, then do the scalar. It's the same operations on integers, just for the record. One thing, notice it's not up here though, because we're going to get into multiplying the matrices together. A times b is not the same as b times a in matrix multiplication. So we're going to talk about that coming at you in a minute. Now, this is kind of a combo, okay, in the sense of it's kind of putting together like the scalar multiplication, some adding, subtracting. It just included one little extra fancy step here for you. Solve for x. Oh, okay, all right. Well, I can solve this for x, right? I'm going to subtract a over. I'm going to do it on the side here. So I'm going to have b minus a. And then you'd have to divide everything by what? 3. Now, to get my final answer, though, we have to use these matrices. So I'm going to do b, start with b minus a, and then we'll divide them by 3. So our final answer will be a matrix. Now careful, start with b, -3 minus 1. 2 minus 0. 4 minus -2. And 1 minus 3. Now your final answer for x, I need all of these numbers over 3. You might have some fractions, but who cares? So I'm just going to kind of get a final answer here. So I'm just going to take everything over 3. It's like you're multiplying by 1/3 as your scalar. So -4/3, 2/3. I'm going to have 6/3. That's the only one that really comes out nice. And then so that is our final answer. Any questions on that guy? All right, nothing exciting here so far today. All right, let's get into matrix multiplication. Matrix multiplication is still easy, but it's not as straightforward as just trying to match up the numbers and multiply them, unfortunately. We're really doing what's called in the fancy world of mathematics the dot product, just for the thrill of knowledge. Now, here's the deal for this, okay? The number of the columns in the second matrix has to match the number of rows, and you'll see me talk about this in the first. If that doesn't match up, I can't do it. So you might have some not possibles today, okay? Now we're going to use, and the order does count here, we're going to use what's called the row column rule. So it's the rows of the first matrix, columns of the second. Do not switch it. It has to be that order. Rows of the first, columns of the second. So here we go. Let me show you. So first, I'm going to check the sizes. I'm going to say, hey, can I even do this? So the size of matrix A, we've got 3 rows, 2 columns. And of course, B is our little square matrix over there, 2 by 2. So first up, in order to multiply matrices together, the number of columns in the second has to answer, these have to match up, basically. They do. So we can do it. Now, the other thing too that kind of helps me here as far as like how much space to set up, like how big of a matrix is my answer, the outside dimensions then is the size of my answer. So my final answer, I'm going to have 3 rows, 2 columns. So I'm just kind of thinking about, okay, how am I going to space that out so I make it all work? So 3 rows, leave yourself some room here. I'm going to write on the left side of this. So I'm just kind of making room for 3 rows. And I'll do my 2 columns in a minute. All right, we are using, remember, row column rule. So it is the rows, A is first, it's the rows of A. So the first thing I'm going to do, I'm just going to jot those numbers down so they're on the outside of my matrix so you know how I'm organizing everything. So I've got -1 and 3 in the first row. I'm just putting a comma between them to separate it. 4 and -2 in the middle row. 5 and 0. Then, it's the columns of B. Well, the first column has -3, -4. So on top of the matrix, I'm going to put -3, -4. Now I'm going to save a little room here. I don't want it too tight on top of each other. My second column, 2, 1. So I'm going to put a little space. Got it. I'm going to close this up. Now here's the deal. This is easy. It's just a lot of calculating. To get your answers, you are basically filling in or matching up the entries on these values. So meaning I'm going to do the first numbers together, then the second. So I'm going to do -1 times -3, 3 times -4. And I'm just going to total that together. So the first answer is going to be -9. Now, some do all the multiplying and total at the end. I don't care how you do it. I'm going to do it as I go in the first one. I don't care if you go across or down or whatever. I'm standing here, so I'm going to do this column first. So I'm going to do 4 and -3, -2 times -4. I'm going to go ahead and total. Then I'm going to do the corner. First numbers together, 5 and -3. I gotta love a 0, because 0 times who cares? Got it. And now I'm going to do everything in that second column. So I'm going to do the first numbers, -1 and 2. And then I'm going to do the second values, 3 and 1. +3, so I'm going to total. I'm going to do underneath next. 4 times 2. Now the second values, -2 and 1. Total. All right, bottom. First numbers 5 and 2. 0 and whatevs. Got it. So the final answer, piece of cake. So matrix multiplication is not as straightforward as just trying to match them up and multiply them. You have to use this row column rule. Now, can you do it on your calculator? Yeah, yeah. And I'll show you, how to type it in and stuff. Personally, I think it's more of a pain in the butt to type it in than just do some mental math. But on your test, of course, this is on the no calculator part. You'll see some of these you got to do by hand. There is some in the calculator part too, just for the record. We'll do the calculator at the end. All right, let's multiply. Well, let's see if we can multiply them, I guess. What's the dimensions of A? How many rows? How many columns? 2 rows, 1 column. 2 across. All right, what are your dimensions of B? 1 row. How many columns? Okay, so inside dimensions match, so we can do it. And I'm like, okay. What's going to be the size of my answer? 2 by 4. So I'm kind of mentally trying to space that out. 2 rows, 4 columns. Okay, a few rows, I think I can do it there. Now, I kind of like this one. I almost think it's going to be less work. Rows of the first matrix. Well, there's only one number, one entry in that row. There's only one entry in this row. Now I'm going to do the columns of B. Only one entry. One entry in column 2. One entry in column 3. One entry in column 4. So the nice thing is, this is going to be fast if you can multiply fast. Unlike the last one, you don't have multiple values to add them together to combine them. You just got to do the straight multiplying, which I see you guys doing, and fill it in. So your first entry is negative what? 15. 5 times negative 3. Now, I don't care you go cross, down, whatever. 6 times negative 3. 5 times negative 1. 6 times negative 1. 5 times negative 1. And what's your last column? What's 5 times negative 9? Negative?
45.
And what's 6 times negative 9?
54.
So this is what I'm saying. I can do that way quicker than it'd take me forever to type the matrices in the calculator and do it all. Sometimes I think it's easier to just mental math it. Any questions on that? All right, couple more multiplying because clearly, you know, that's the more I love the enthusiasm here. All right, let's first check if we can do it. What are your dimensions of A? 2 rows, 3 columns. What's your dimensions of B? 2 by 2, little square. Can you do it? Nope, not possible. These do not match. Yay. Can't beat that. All right, questions about that guy? I'm assuming not. Okay, so let's check it. A, of course, 3 by 3. B, 3 by 2. So we can do this one. Those inside dimensions match. What's the size of your answer? 3 by 2. So I'm kind of spacing out in my mind 3 rows here. So here we go. Again, just leave a little room on the side because I'm going to put the numbers down next to it that we're going to multiply. So I'm leaving myself some room here on purpose. Now remember, it's the rows of the first matrix. So, oh man, we're going to have to do a lot of calculating here because we have 3 values in there. I'm like, oh gosh, okay. We're going to do negative 1, 1, and negative 2. My middle row, 3, 0, 4. And then my bottom row, 4, 2, negative 3. Yeah, okay, all right. So we got to do 3 numbers here. Okay, first column of B, 2, 1, negative 5. Now because I know I've got to do 1, 2, 3 calculations, I'm shimmying over. I'm leaving some room here, okay? So 7, 1, 3. Leave a little room. Okay, so easy still, just tedious because we have so many things to multiply. So we're going to do the first coordinates together, negative 1 and 2. We're going to do the middles, 1 and 1, positive 1, so plus 1, negative 2, negative 5. Now I'm going to go ahead and total this up, 11 minus 2 really. All right, keep going, it's just time consuming. 3 times 2, 0 times who cares, 4 times negative 5. And I don't know how to have it. I always total it up as I go. 6 minus 20. You can do the totaling all at the end if you want. 4 times 2. Middle numbers 2 and 1. Third number is negative 3, negative 5. So 10 plus 15. Got it. So let's get our second column going. First numbers, negative 1 and 7. 1 and negative 1. Negative 2 and 3. Total, what do you got for that one? Negative 14. All right, here we go. 3 times 7. 0 times whatevs. 4 times 3. What is 21 plus 12? 33. All right, let's do the last one then. 4 times 7. Middle numbers, 2 times negative 1. This is a sloppy 8 right there. And then negative 3 times 3. So total that up, what's your last number? 17. Got it. So I still think it's way easier than Gauss-Jordan, agree with that. But multiplying matrices is obviously a little more work than the adding, subtracting, okay? All right, last one of these, and like I said, I will show you on your calculator. All right, order matters when you multiply, just for the record. So first we're going to do A times B. So they're both 2 by 2s. Clearly we can do it. Now, as always, I'm going to leave a little room to write next to it the values. So I'm going to put my little off to the side on purpose. So rows of the first matrix. And then it's columns of the second. So 2 and -1. And my second column would be -1A. Bless you. All right, same spiel. Start multiplying, add them, let's do it. So 1 times 2, 2 times -1. I'm going to total 4 times 2, 2 times -1. Keep on going. First values, 1 and -1, 2 and 8. I'm going to total. And then 4 and -1, 2 and 8. And I'm going to total. Got it. So there's A times B. Yeah, we just have so much to do. Okay, B times A. Again, leave some space. I'm just going to erase all my stuff up here. I wrote all over. Okay. So let's do, now remember, row, column. Rows of B. Leave some room. Rows of B. And then it's the columns of A. So the first column of A, 1 and 4. Second column of A, 2 and 2. All right, just take it away. Here we go. 2 times 1, -1 times 4. I'm going to total. So as you can see already, they're not the same thing. A times B, B times A are not the same thing. Okay? All right, keep going. -1 and 1, 8 and 4. 2 times 2, 2 and -1. All right, final entry, -1 and 2. I feel like I'm playing bingo here. 8 times 2, 14. Got it. Okay, all right. Questions on that? And we're still going. Still going, kids, still going. What's the, just because I want you to find so many things, what's the last thing I have to find? A squared, which is really A times A. So let me scroll this down here a smidge. So I'm going to write A times A here. Now I'm going to go back up so I can see the entries. Let me do a little erase job here too. So we're all on A. So first thing I'm going to write down, remember, row, column. Rows of A, 1, 2, 4, 2. 1, 2, 4, 2. Now, I'm going to scroll it back up to A. Seems weird, but we can do it. I'm going to write down the columns of A. 1, 4, 2, 2. I need a bigger board. 1, 4, 2, 2. And then I'm just going to take it away and start multiplying and combining. Okay, 1 and 1, 2 and 4. I'm going to have 9 for my first entry. 4 and 1, 2 and 4. You guys are already done? 1 and 2, 2 and 2. And then 4 and 2, 2 and 2. Got it. Okay, any questions on the A squared? So last thing I'm going to show you, just for the thrill of knowledge, I guess, is if you wanted to do it on your graphing calculator. Because like I said, I mean, you can always do it by hand, but there are some of these on the calculator part. So let's do this guy here. Let me erase all of this writing so we can see the numbers. Eraser. So we can see all the numbers here. All right, matrix menu, you know the drill. Matrix menu, edit. Okay. Now, same spiel as yesterday. Matrix menu, edit. I'm going to use A for this one. Obviously B for the second one. Here we go. Let's start typing. So second x to the -1. I'm going to go over to edit. I'm going to use A, of course, first. Now, this is from yesterday's stuff, so I got to change the size out. Our A is now 3 by 3. And just start typing in the values. -1. What do we got? 304. So I feel like I could have done this by hand quicker than me typing these dumb things in, but okay. Just to show you. Okay, I'm just making sure I don't have a typo. Okay, once you're done with that, I'm going to get back into my matrix menu, and I'm going to go to B, though. I got to enter in matrix B. So you can stay in this, it doesn't matter. Just second x to the -1. I got to go to edit, and I'm going to, number 2, put in our B matrix, which I got to look at. B is a 3 by 2 here. 3 by 2. And I'm just going to grab my notes so I don't have to keep moving my calculator. Just start typing that guy in. I'm just making sure I don't have a typo. Okay, looks good. Got it. So just like you had to yesterday to do the reduced row echelon form, I'm going to quit out and get back to the home screen. So second mode, I'm going to pull up matrix A. I'm going to hit the times button. I'm going to pull up B. So second matrix A times, back into your matrix menu. Oh, come on, I hate this one. I feel like I could have done it faster by hand. What do you think? Yeah, but I just wanted to show you, so if you want to check anything, anytime, whatever, you can do it in your calculator. I personally think it's quicker by hand, okay? Any questions on that? All right, so obviously you got a worksheet for homework, just kind of, the 4-day weekend, obviously. So when we come back on Tuesday, we're just going to practice some of this stuff, your Gauss-Jordan elimination, and this should be Tuesday, Wednesday, kids, Tuesday, Wednesday. Forgot we had Monday off. There we go. And then Wednesday, you'll have your no graphing calculator quiz over Gauss-Jordan and some of this adding, subtracting, multiplying. Now, one thing too, this is what I'm kind of telling you here over the weekend, no graphing calculator. If you are worried like you're going to mess up 4 times 7, you could use a scientific calculator if you have one. I used to have like half a dozen of them, but they've all been stolen over the years, kids. Fun facts. But if you have a little scientific calculator at home, you want to steal one from a younger sibling maybe or something over the weekend, you can use that on the quiz. If you're worried about basic computation, judgment, no judgment, but of course no graphing calculator. Okay?